Christmas, and we're looking for something to give as a present. And in these times when inflation is riding high, and some of us are paying really expensive energy bills, this is a perfect time, I believe, to be repairing stuff and to give it as a present to somebody we like or we love. All the screws that need to be taken out are indicated by a little arrow symbol you see right there. Okay, and every screw that needs to be taken out is indicated by the same kind of arrow. Contrary to what I'm used to from Sony is where normally they make the radios and TVs and stuff they design easy to disassemble for repair. This time they made it a little more difficult. Now, behind this blue plastic cover here, which covers the dial, alright, there are two screws hidden that I need to undo. So there's one at the top here and one here at the bottom. But unfortunately for me, this blue cover is held on by tiny screws right here. Okay, and unfortunately you need a very fine little Phillips screwdriver like this, okay, to undo the screws. Yeah, this is not something I'm used from Sony. I mean, usually Sony doesn't make things that hard to do. Alright, so there you go. One little screw taken out. Now the next one at the top here. Undoing the buttons, or taking them off really, is just a matter of pulling rather hard on them. But there you go, they just let go from these studs here. Alright, and you do need to pull the tuning knob loose, because hidden behind the tuning knob there is a tiny one of those stupid tiny little screws hidden right here where I'm pointing at with my screwdriver. Alright, so here we go. There you go. You don't want to be too brutal with this if you don't want to break it. So let me see, something is catching here. But what? Ah, there you go. Okay. Oop, there's a screw for the antenna that I need to undo. Okay, so on the inside there's an antenna right there. Okay, so and you need to unscrew this, otherwise you're going to rip off this cable. Now it's okay to unscrew it. You will remount it anyhow once you're done doing the cabinet. But you know, the easiest way temporarily would be to unsolder the wire. Not surprisingly, Sony kept it really neat on the inside the radio. The print boards that are necessary to run the radio are really nice, and they built even a separate little print board or PCB for the power switch. So that's a nice touch. Also, this one, which is mounted on the backside of the case of the radio, is the power supply board. And then, of course, on the other side we have a very flat speaker, a 3 watt 8 ohms speaker, and the radio PCB right there, together with the rod antenna for the AM band. Nice. It's a really simple design, but very clean and very effective, as we are used from Sony. It's all really easy to unmount. It's just a few screws, and that's it. And it's all the same screws, so no need to worry about which screw goes where later on when we need to build it all back in. Now, I do need to undo the fuse right there, and it's like I suspected. The fuse is connected to the B+, so to the output DC voltage of the power supply. Unfortunately, they used some hot glue to secure it to the case of the radio. So what I'm going to do is, first I'm going to try with my solder iron to heat up this glue and see if I can get it loose that way. If not, I might have to use the heat gun to pry it loose. I'd rather not, because all of this is plastic, and if you're not careful you might damage the plastic, you see, because plastic has the tendency to become soft and to warp if it's subjected to too much heat. Alright, so yeah, once that is done, the only thing I need to disconnect is the radio PCB itself, right here. There are several electrolytics down there that I want to reach to replace them. Now, although technically speaking I could reach in there with my fingers and pull the capacitors from there, but it would be a little bit easier if I could undo this black cover. Yeah, and in fact it turns out the cover is held on by a few screws, which obligingly Sony indicated by that double arrow symbol. Yeah, but also by a few plastic clips, and one of those clips is right here. Yeah, and I undid all of them, but I still can't seem to get the black case loose, and I suspect the reason is that I need to undo the screw from the tuning capacitor. Let's see if my hunch is correct, and I'm going to set the tuning dial, or one end. Yeah, okay, so I'm going to set the tuning to one end. Okay, so that makes my life a little easier later on when I want to mount everything back. So here we go. Alright. they apparently used some Loctite on the screw, so they really took efforts to make sure that the tuning capacitor would never come loose. So let me see. If I can pull this loose now without breaking anything. It's hung up somewhere still. I don't know where. Here maybe. There you go. Alright, now that makes things a lot easier to work on. So here you go. This is the inside of that black housing. Okay. So, and the tuning capacitor's knob. Cool. So now I can work on replacing the capacitors without damaging anything on the print boards. Alright, so the next thing we need to do is replace 1, 2, 3, 4, 5, 6, 7 capacitors on the radio board and 1 capacitor on the power supply. By the way, the power supply has this neat little metal cover which is built around it, around the transformer, to probably shield the radio from the 50 Hertz. Another thing that I noticed is that there's no fuse on the 220. So, and that's something I'm going to correct yet again. I'm going to mount a fuse holder and a fuse on the 220. I mean, that's the least you can do to make something safe. Alright, I'm going to desolder all the electrolytics on the main board with my desoldering gun. But before I do that, I replaced the original filter in my gun, and as you can tell, this is the filter I removed, and it is encrusted with solder. And basically after 1 or 2 projects on average, you need to replace this little felt filter. This is basically felt, a couple of millimeter, maybe even 3, thick. Alright, and it is meant to stop the molten lead you suck off a PCB with your desoldering gun. And the filter is located, let me show you. Come on. Hang on. Yeah, there you go. The filter is located basically in this little glass tube, well, plexiglass tube, at the rear of the desoldering gun. Alright, so you unlock the stock of the gun, and then you can basically push the, there you go, you can basically push a little piston which is located at the back, yeah, you can push the piston back and then lift out the little plexiglass tube and place in a new filter right there. Then you press the tube back in and then you press the stock back forward until it locks. Come on. There you go. Alright. Now, at the center of the plunger, there is basically a hole which sucks away the air inside the tube through this tube here, the thickest tube, yeah, and out to the pump on the main base of the desoldering gun. So, over there really. So, that is the base of the desoldering pump. Now, I haven't cleaned, ever since I've owned this desoldering gun, I haven't cleaned out the desoldering pump itself. And I think it's overdue. Because I can feel there's a certain degradation in the suction power of the desoldering gun. There you go. Old filter I dispose of in a can, which I use especially for that sort of rubbish. And when a can is full, I just bring it to the municipal dump where they have a special container for dangerous garbage, you know, like lead and quicksilver and all that sort of stuff. When you replace electrolytic capacitors, it's always a good thing to, well, first of all, make plenty of pictures, of course, of the PCB, but also to note which way the capacitors are orientated on the PCB, alright? So electrolytics have a negative pole, yeah, which is often indicated by a full line with minuses drawn on them, okay? And the other side is automatically the positive side, or the anode, okay? So cathode, anode. Now, on the PCB of this Sony radio, the engineers marked the negative side of the capacitors with a little symbol here. And in this case, the dot indicates the cathode or negative side of the electrolytics. Now, a small word of caution, and not all electrolytics have their negative poles indicated by a full line, you know, like this one here, alright? So this one happens to be the negative. There are those, on very rare occasion, which have their positive on the full line. So whenever you replace electrolytics, it's always a good thing to double check. The Bluetooth transmitter, which I built right here, well, I would say the Bluetooth receiver AM transmitter I built here, is connected up temporarily to my lab power supply over there. And there's a power regulator on the print board right here. So I'm using an LM317 to put the voltage down to around about 5 volts DC. In fact, I can show you. So right now I'm pumping in 5.01 volts DC into the whole Bluetooth interface, so I would say the Bluetooth AM interface. Now I paired it up to my smartphone, and my smartphone is set to a radio, a local radio. Okay, so now I tuned my lab tuner to to a to the frequency of 1 megahertz. Alright, so you can see my AM radio over there. Alright, so right there, and I can give you a very short view of what it would sound like while it's transmitting the signal. So you see the blue LED right here, yeah, is not flashing, meaning that it is connected up to my smartphone. So yeah, let's have a go at it. So I can only make you listen a short while for obvious reasons, okay, because well, for copyright reasons I can't linger, but listen to this. And I can set the volume right here. Alright, basically, as the saying goes, one picture is clearer than 1,000 words, right? So, basically, what I built here is a little power regulator circuit right here with the LM317 power regulator right here. So this is the LM317, which in turn feeds a little oscillator built around an oscillator chip, which internally, so this is the oscillator chip here, which internally has a crystal running at 1 megahertz. Alright, so basically this little chip here outputs a very precise 1 megahertz frequency, you could say square wave signal, yeah, and that signal is then sent to this little NPN transistor here, which is a BC547, which basically functions as a little amplifier for the signal coming from the IC. Alright, actually it's more like an amplifier mixer because basically the oscillator chip is sending its square waves into the base of this little transistor, and the carrier wave, the 1 megahertz carrier wave, is then mixed with the audio which comes from the Bluetooth module, yeah, into the carrier wave via this little transistor here. Alright, and then of course it goes to the antenna output, which is here, this little contact here. So obviously I didn't build the Bluetooth module, I just bought it. Now there was one annoying little, well actually two annoying little details about the Bluetooth module. It is built to output a rather strong signal, audio signal, to drive little speakers, okay, which is way too much, let's say, energy to pump into the mixer amplifier transistor you see here. Okay, so that is one problem. The other problem is that its output is stereo. So in other words, since AM is mono, I needed to mix the two output signals together before, and that happens via these two little trimmers you see here, 1, 2, and these two capacitors. So I mix the stereo signal into the mixer or amplifier transistor you see here. Yeah? Okay, and so the high frequency signal, so the carrier signal which carries the audio, exits here from this pin and goes to an antenna, which basically will be a small coil of very thin enameled copper wire, so something like this. Alright, so wire like this. Okay, so it'll be a small spool which will be located inside the portable radio and not too far from its ferrite rod antenna. Okay, so there you go. In a few words, this is what you see. So the power regulator, which regulates the voltage to 5 volts, which the chip needs. And by the way, the Bluetooth module also needs 5 volts. Okay, so then you have the oscillator, which is basically this little chip here. Then you have an amplifier mixer, which is this little transistor here, and a number of components around it. Yeah, and then you have the sound mixer, which is these two trimmers here, 1 and 2, and these two capacitors, 1 and 2. Okay, and these two mix the stereo sound into mono, which is then injected into the amplifier mixer transistor you see right here. Okay, and then this is just a Bluetooth module I bought online. So there you go. That's basically what all this is. Next, we're going to build this into the portable radio and see if it still functions normally when fed via the power supply of the portable radio. By the way, just so you know, I checked the current draw of my little device here, and it's around about 35 milliamps. So that really shouldn't put a heavy load on the portable radio. From the schematic, we know that the power supply of the Sony portable radio should supply somewhere around 9 volts DC. So I never actually measured how much the power supply, let's say, supplies in reality. So when it is actually connected up to the AC. So that's exactly what I did. I connected only the power supply of the radio to the AC, and I connected my multimeter up to the B+, so the output, the DC output of the power supply. So my guess is it shouldn't be too far from what is indicated on the schematic. So it should be somewhere in the ballpark of 9 volts DC. So I'm going to switch it on now. Now don't worry, this part here is away from any AC. Okay, so this is purely DC. Okay, so here we go. Alright, so I'm going to switch it on right now. Okay, 7.9 volts DC. Yeah, that's a little bit more than a volt less than what the schematic says the power supply should output. I guess that shouldn't be a problem. Generally, those things, the radios and such, are designed to work within a certain range of DC voltage. And for our little hybrid module we built, yeah, for transmitting via Bluetooth music over an AM signal, that should be just right, just perfect. So yeah, well, there you go. So the output voltage of the power supply of the portable radio is 7.9 volts DC without a load. Alright, I've got the volume of the radio turned down for the moment, but it's already paired with my smartphone. Okay, so what I propose to do is to run through several radio stations on my smartphone and pass them on via the Bluetooth to the Sony, which is now tuned exactly to the frequency of the AM transmitter I built here, and just run through a few stations, just for fun. So keep in mind, I just can't linger on any particular channel for very long. Okay, so let me see here. Let's start with that. Alright, here we go. Not every station is available here. Let's see, this one. Okay. See this one. Well, that's a weak station. Let's see here, this one. No? Oh, okay. This? Yeah, like I said, not every station is available where I am. Okay, so you see it works, and also another detail is that if you set the volume too high of your smartphone, the sound, the volume on the radio will be overdriven and heavily distorted. So you need to find, let's say, a happy medium where the sound is clear but not distorted. By playing around a little bit with the volume on your smartphone. Also, remember there are two potentiometers, or I should say two trimmers, on the AM transmitter board with which you can set the maximum signal input, audio signal input strength. Okay, so you need to find a happy medium between the output of your smartphone and the settings of the trimmers on the board. Okay. Alright, a few words of explanation on the schematic of the hybrid circuit that I'm using in the Sony ICF-704. It's basically it's quite simple. You have two parts, which is on the one hand the Bluetooth module, which I bought, by the way, and on the other hand you have the AM transmitter circuit, which I designed and built myself. Now, the AM transmitter circuit comprises three sub-circuits, you could say. The first one being the voltage controller, which is this part here, which is built around an LM317, which is set to output plus 5 volts DC. The second subpart is built around a crystal oscillator, which is basically one chip, and it's an MX045, which runs at 1 megahertz. Yeah, and then you have the third part, which is a mixer attenuator, which is basically this part here with these trimmers included. Alright, and the function of this is really to send out a carrier wave to the antenna, and on the other hand to mix the sound outputs, and I say outputs because the Bluetooth module has a left and a right channel. Okay, so it mixes the outputs of the left and right output channels of the Bluetooth module to modulate the carrier wave, because remember we're talking about an AM transmitter, so the carrier wave needs to be modulated in its amplitude. Okay, we're talking about amplitude modulation. Now, you could say my misfortune was that the Bluetooth module has a left and a right, so a stereo output. But in the end, making a very simple, small mixer, yeah, allows me to mix both channels into the output of the transmitter. I mean, AM is mono basically, so that really doesn't matter. Now, there is a small, you could say, a bit strange part, which is the collector circuit, which is this. This is basically a tank circuit, and the reason why I use it, well, there are actually two reasons. One is I was feeling a bit adventurous and I wanted to experiment with such a circuit, and secondly, it helps to attenuate the output signal somewhat, because as you all know, the FCC is quite strict on transmitter power, output power. Okay, so I needed to make sure that it would never exceed, let's say, the 50 milliwatts transmission strength, let's say. And the tank circuit turns out to be quite effective in attenuating the output power. The tank circuit is built such that it attenuates maximally at the exact resonant frequency of 1 megahertz. You'll remember the MX045 outputs an exact or nearly exact frequency of 1 megahertz. The tank circuit has its maximum reactance, so you could say a maximum resistance to a frequency of 1 megahertz if you use a 320 microhenry coil and a 79 picofarad output, capacitor on the tank circuit or in the tank circuit. Now, I noticed that, at least for myself, I had the best result using a capacitor of 47 picofarad. Alright, and that works great in the radio. And you'll see later on in the video that I switched from using a copper coil as antenna to a direct coupling to the antenna of the radio itself. Why did I do that? Well, simply because I tested it out, and apparently I get the best results by coupling it directly to the antenna of the radio and not work through a coil in this case. If you're going to use this device, let's say, standalone, so not built into a radio, in my opinion, you would do better to use a copper coil as an antenna. Okay. Either way, you'll have to experiment a little bit with the length of the wire and the number of turns and the spool to get a maximum result. So let's say a strong signal that goes to any AM radio in the neighborhood. Now remember, you should check whether you're bothering your neighbor or not with this transmitter, and like I said, the FCC is quite strict in that sort of stuff. Now, like I said, the best result I get with a 47 picofarad in the tank circuit here. Alright? If you look around on the internet, you'll find all sorts of formulas which allow you to calculate the impedance, I should say the reactance of this circuit, and I'll include a link to such a site below the video. Also, you could increase the transmission strength by lowering even more this capacitor here in value, but of course there is a limit. I mean, technically you could even leave it out completely, leave out the capacitor, and that theoretically would give you maximum transmission power. But remember, the circuit in itself has a sort of you could say, a natural capacitance, so it will be clamped down either way whether you leave out a capacitor or use a very small capacitor. Okay, either way, it's up to you to experiment a little bit with the values you see here. I just wrote down, let's say, the quote-unquote optimal values. So one last tip I have for you all, that is that before you insert the oscillator, the crystal oscillator, and you attach the Bluetooth module to the circuit, because as you can tell here in the schematic, the oscillator and the Bluetooth circuit both use 5 volts DC. Yeah? Before you connect those two up, you should set the output voltage of the LM317 to 5 volts plus 5 volts DC. Okay? That's important. If you don't do that and it outputs, if you forget to do this, and it should by coincidence output a lot more than plus 5 volts, you could ruin your oscillator and your Bluetooth module. Yeah? Also, you should never input more than, I wrote 35 volts. Technically, the LM317 is rated for, if I'm not mistaken, 37 volts DC input voltage. Okay, so there you go. You can experiment a little bit if you wish, yeah, or you can change it completely if you wish, but for me at least, this gave me very satisfactory results. Now most of the electronics are taken care of. It's time to subject the case of the Sony to a closer inspection and to repair, where necessary, blemishes. Now you can see overall this radio has been heavily used, and I don't think a simple cleaning will do. Well, a simple cleaning won't do. Yeah? There are some deep gouges and scratches, and before I give this a fresh coating of paint, I just need to take care of these gouges everywhere. So the way I think I'm going to do this is with some sanding paper and a very sharp surgical knife, dressing up these damages, which I will then afterwards repair with some very slow setting but very strong industrial glue. So either way, oh, and I will also have to replace the lost logo, which was which originally was here but is lost. So in the lower left corner there are some damages that will need repair, and there is some damage right here. I don't know how I'm going to repair this, because this looks mighty difficult to repair, but I'll give it a go. Okay, so then there are some scratches, obviously, which also will need some repair, and then on the back part of the cabinet or the case, there are also some scratches and gouges. So mainly right here. Okay, so come on, focus, right here. Okay, this will need some repairing as well. Yeah, and of course there are the scratchers and like the heavy pitting and gouging you see here. So I will take care of these, like for example this or these here, with a little bit of light sanding, and possibly filling up the larger ones with a little bit of that industrial glue. And once all that is done, what I need to do is to tape off what I do not want to be covered in paint. So mainly in this case the antenna and possibly the carrying handle, although I'm not sure I want to leave it as it is. I mean, the back is okay, but the front could certainly do with a little bit of of a freshening up. So yeah, there's quite a bit of work to do on this case, which by the way is extruded plastic, as you can tell on the inside. Yeah, so yeah, the first thing I'll do is get rid of what I do not need, like these stickers here. I don't know why these were glued on the case, but I guess maybe it's a sort of a reference number, or a stock reference number or something. Either way, I'm going to get rid of those, and then I'm going to give the whole case a thorough cleaning and degreasing once I'm done. And yeah, and that's it. And then we'll give it a ground layer, and then and a few coats of matte silver paint. I'm using 320 grit sandpaper to gradually sand down all the dings and scratches I find on the cabinet. Now, this is dry sanding, and the 320 grit works best, I think, on hard plastic like this. Now, remember, this is plastic, so whatever you take off with sandpaper makes the plastic thinner and therefore more brittler. Okay. Also, you need to be careful when sanding around edges like these. Okay. So you should always sand with the edge like this. For example, this edge is hollow like this. I'm exaggerating now, but that's what it is. It's hollow, you see. So I'm taking care not to sand over the edge itself, but along the edge. And if the plastic goes like this, then I try to keep the sandpaper in exactly the same shape. This is round like this, so convex. Okay, this is concave, this is convex. So I try to sand right along the edge, but not on the edge itself, and always with the shape of the plastic. So what I want to say is you don't need to sand off a huge lot. Okay, you only need to sand off just enough so that you don't feel any irregularities anymore in the plastic, or nearly so. The weather today is cooperating. It's pretty dry, not too much wind, and it's about 19 to 20 degrees Celsius, which is perfect to do some painting outdoors. As you can tell, the primer layer on both parts of the cabinet is dry. Actually, I ended up having to spray about 4 coatings of primer, and let's say 90% of all the blemishes are gone, or only very slightly visible. But I don't think I can get it much better, that is, without shaving too much plastic off of the cabinet. So I think I'm going to leave it as it is. I'm not going to do anything more to it, except, of course, spraying the finish layer on the primer. And I am going to use white aluminum, which has the color code RAL 9006. Yeah, it's dull white aluminum, so it's not shiny. Yeah, but I think this is the color that will probably go best with the case, which let's say approaches best the original color. As an added touch to this radio, since we upgraded it with Bluetooth, I'm going to place a little Bluetooth symbol on the dial face, right about here somewhere, to indicate that this radio has been upgraded with Bluetooth. You'll notice that the engineers at Sony were really nice in helping techs servicing the radio, and in fact they indicated by little arrows on the PCB where you need to put back the screws to hold the main PCB down. There are three, in fact, as you can tell, and yeah, the whole radio is full of little indicators like that, so it's good to keep an eye on those, and of course to always take plenty of pictures. Also, remember, there's the band switch right here you need to put back, and if the print board doesn't fit right in right away, do check whether the band switch coincides with the switch lever, which is located under my finger here. Let me show you. So, right there. Alright, right there. It's handier to unsolder the wires from the speaker. So, yeah, that's just another tip I can give you. Okay, so unsolder the speaker from its wires and put it away somewhere safe so that you don't damage the cone. Alright, I made a last minute change to the setup. I tried out the little coil antenna that I had made for my AM transmitter, but it just doesn't seem to perform as well as I had hoped. And while I was figuring out why the coil antenna wasn't performing as well as I had hoped for, I just, thought, well, why not make use of the antenna of the radio itself as a, let's say, an antenna for my AM transmitter. And in fact, that's exactly what I did. I connected up the AM transmitter. You see it down there. Alright. And I connected it up to the antenna of the radio itself via a 100 picofarad 50 volts capacitor, and there you go. The wire is about 4 inches long. Doesn't need to be much longer than that, and in fact this length I found out by experimenting a little is the ideal length. Okay, so about 4 inches of wire and a 100 picofarad capacitor connected up to the antenna of the radio itself, and it doesn't interfere with anything else. So I tried out the FM band of the radio. It works perfectly even when my little AM transmitter is working and the Bluetooth is working. So there's absolutely no interference whatsoever, which, let's face it, is logical since this is a completely different frequency and a completely different modulation method. So yeah, they don't interfere with each other. Alright, there you go. The whole radio is now reassembled and tested, and it works great. So the only thing I need to do now is apply the finishing touch and rebadging it with its logo. Yeah. And once that is on, then the radio is truly finished. Alright, so there it is, finished and completely assembled. As a finishing touch, I added a new logo right here. And I also added the Bluetooth logo on the dial face. Alright, just as an added little touch to show that this radio has been converted to Bluetooth reception as well. Now, there's a nifty little detail that I forgot to show you, which is that when you switch on the radio and therefore the Bluetooth module, the Bluetooth module alerts you via a little tone, a little music, that it is there, and its LED starts to flash. Now, I located the module, the Bluetooth module, at the back right here, so that you can see the LED flash. Now, when it's flashing quickly, it's not paired up, but when you press on your smartphone, for example, Bluetooth, yeah, you will see that it's trying to pair up with a module called MH-M38. Alright? Once it is paired up with the module, there you go, the LED stays on permanently. Okay? And when you start sending through sound, then it flashes slowly, yeah, to tell you that it is receiving music. Alright, so I'm sending through an FM radio station that I can receive on my smartphone. Alright, and it's coming through on the AM. Okay, there you go. So it's now paired up and it's sending an FM channel, which I'm receiving on 104.1 FM. Now, I can't let you listen to the music too long because of possible copy strikes, but I can show you that it is actually paired up with the radio now. You see? You could set the volume on your smartphone too, of course. But you should never set the sound too loud on your smartphone, okay? Because you'll notice once you set the volume too loud, the sound on the radio will start to distort. Okay? So there you go. I hope you enjoyed watching the restoration and the upgrading of a Sony radio, namely an ICF-704S. Okay, so I hope you enjoyed watching me restore and upgrade a Sony ICF-704S radio. And if you're going to do the same thing, you can make it a beautiful present to somebody, you know, and make something which is potentially obsolete up to date with the 21st century. Thanks for watching.